I've been using this inverter for about 5 months and it's been working really well. It's a 3000 watt inverter made by Reliable Electric. It's a 48 volt input from the batteries and 120 volt 60 hertz output for the North American market where I live. Reliable Electric reached out to me and asked me to help them make a video that would answer some of the common questions that they receive, and in doing so they're going to send me out another inverter that I get to test and try out. So I thought it was a good win-win. Like I said, I bought this one though with my own money, and I'm just going to show you how I hook it up, how these terminal blocks work, what kind of comes with it. So let's go in. It comes with cables, so you don't have to go out and buy some if these cables work for you. It also comes with spare fuses, so there are fuses inside here that are replaceable, which is a good thing in case you short something out. And it comes with a little manual. The other thing is, inside the plastic bag, it comes with this little plastic cover, which is meant to go right here and cover the terminal blocks after you get it wired. Now these cables are adequate for a lot of work, but if you're going to be mounting this inverter farther away from the battery, or you're constantly going to have this under a heavy load, you may want to upgrade the cables to something heavier. However, I've been using the cables for probably 3 out of the 5 months, and when I switched to a thicker cable, I didn't see any difference in the way that things ran. That's just my own personal experience with it. On the back of the inverter are 2 cooling fans. These are blowing out, so when you hook this up, you want to make sure that you don't block these fans with anything. Allow the air to blow through and the unit to cool itself. We have the negative post and the positive post. These will go to your battery. Over here on the front of the unit are 2 indicator lights. This one's a fault, and this one is just when it's operating in normal condition. Then we have 2 displays. These are both going to show voltage. The smaller one is going to show your battery voltage, and the larger one is going to be your output voltage. So this is going to be your DC, and this is going to be your alternating current, your AC. On-off switch. We have 2 outlets here, and for the North American market we have this style outlet, and then we also have a terminal block. On the bottom of the unit we have a label and a grounding lug. This center post is also grounded. So let's talk about the 2 ways you can get power out of the inverter, and that's the outlets and the terminal block. Now the outlets have thin gauge wire leading to them, which is perfectly fine if you're doing something like charging your batteries for cordless tools. I do this all the time, where I just plug the charger directly into these outlets, no problem. However, if you're drawing something that's a heavy load, you don't want to draw it off of these. You want to draw it off of the terminal block because they're heavier gauge wires and you won't have as much voltage drop. I'm going to show hooking that up later. When you go to hook this up, you're going to take off the hardware from the stud, and that's going to reveal the plate down here. This is part of the copper plate that goes into the unit. So this is where you want that electrical connection to be really good. So you're going to take your cables and you're going to put your cables on here, and you want to make sure that that cable is on that connection nice and tight. And then if you're going to hook up 2 cables like I do, then you're going to take the second cable, and don't put them on together like that because they won't have a good clean connection. You want to twist the second one. That's going to be a better connection. Then you'll put your flat washer on first, then your lock washer, and finally you'll follow it up with your nut. And I'm just going to tighten these up. Okay, all the wires are tight and they're not loose when I move them. I typically have this inverter screwed up against this wall, but I moved it out for the purpose of the video so that you can see what I'm doing. First thing we'll do is take the negative battery cables, and this is going to be my negative bus bar from my batteries. Check them and make sure they don't wiggle. They're nice and secure. Now for the positive. You could hook the positive directly up to the bus bar because there's fuses built into this. And I did that for a while, but I recommend adding an inline DC fuse, so that's what I'm going to do. So here's the terminal block, and I just removed these bottom screws. Now I'm going to take this wire and I'm going to hardwire it to this outlet over here so that I can run some more powerful tools. Now what I can do is I can take the screw and I'm going to put the screws in and tighten that down. According to the manufacturer, the yellow is your ground, black is your neutral, and red is your hot. I'm going to go give these all another good tightening. And then last step, check your fuse bag that came with the inverter. There's this little plastic cover, and put the plastic cover over that terminal block. Okay, so now we have these outlets that are available for low power draw items, and we've hooked up an outlet over here for high power draw items. So let's go ahead and turn the inverter on, just like that. And we can see on the display we have 48.7 volts from the battery. We're outputting 119 volts, and we have a blue indicator light, so all is good. Now for low draw items such as this DeWalt battery charger, I can just plug it directly in to the outlets that are right here, and you can see that it's blinking and it's going to charge that battery up. And that works just fine. But remember, these have fairly small wires going to them, so for heavy items we're going to want to use the terminal block. This DeWalt miter saw is pretty big and powerful, so I don't want to hook this up to the small outlet. I'd rather go over here because this outlet is going to be hardwired in. And as you can see, when I plug that in, light turned on, and we can run it. I'm glad that this inverter has the ability to run the miter saw. It means that in a backup situation, I could run the saw. However, this is 1800 watts. I notice that this is less powerful on the inverter than the wall outlet from the grid. So I like this inverter. Even though I don't want to run an 1800 watt load off of it all the time like the saw, I do run my chargers off of it. Sometimes I have a whole bank of chargers lined up, and I have cooled this garage with a small window AC which draws a little over 400 watts, and it has worked all summer long for me. So I hope that's helpful and you've enjoyed the video. Thanks for watching.